Question 9 is a nice little proof. So you're given what this differentiates to give, but we've got to try and show how you get there. So the first thing we've got to try and think of is, would you agree that A is the same as e to the ln A? In that these two things would just cancel each other out, wouldn't they, if we had there? So A is equal to e to the ln A. So I'm going to write this as e to the ln A times by to the power of kx. Next thing, well, what we've got here is something to the power. And the rule you should remember here, I mean, if I did 2 to the power of 3 all to the power of a 4, you'd agree that that was 2 to the power of 12. Your power rule says we times these two things together. And so that's what I'm going to do. I'm going to write e to the ln A, going to be careful how I write this, times by k times by x. And so we've got that there. Now we can differentiate this now then, dy by dx, because we know that e to the anything x differentiates to e to the anything x times by that anything. So that's what I'm going to get here. So I've got e to the, all of that just stays the same. And what am I doing? I'm timesing by how many x's there are. Well, how many x's there are is there are k ln A of them. So I'm going to put k ln A. I hope you can read that. That says k ln A there. And so now let's unwrap it all again. Outside here, I'll write it clearer this time. I've got k ln A. And that thing there, well, actually, that's what I've been playing with all the time. So that is exactly the same as a to the kx. And that is what we were asked to show, I think. A to the kx, k ln A. Finished.